Welcome to the video on how to calculate FiO2 concentration with air and nitrous. Okay, let's talk about flow meters. So here's our flow meter for oxygen in liters per minute. And when we adjust our flow meter to 1 liter per minute, we know that we're providing 100% FiO2. As a matter of fact, even if our flow meter is adjusted to 5 liters per minute, we're still administering 100% FiO2. If we set our flow meter to 10 liters per minute, we're still administering FiO2. Sometimes 100% FiO2 is written as 1.0. So as long as the only gas we're administering is oxygen, the FiO2 is 100% regardless of the flow rate. So here's the question. How do we calculate the FiO2 when we introduce another gas that we're using while also using oxygen? There are several ways to figure this out. This is just the method that I would use. FiO2 equals liters per minute of oxygen divided by liters per minute of oxygen plus liters per minute of nitrous oxide. So now we need to plug our numbers in. So let's say we are using 2 liters per minute of oxygen and 2 liters per minute of nitrous. So let's plug in our numbers. FiO2 equals 2 liters per minute of oxygen divided by 2 liters per minute of oxygen plus 2 liters per minute of nitrous oxide. So this will be 2, and then 2 plus 2 is 4. Let's reduce this to the lowest common denominator, which is 1/2. And our FiO2 will be 0.5 or 50%. Now, of course, most people could look at this and wouldn't have to use the mathematical calculation. But I wanted to apply it to a very simple flow meter arrangement before we move on to more complicated flow meter arrangements. Okay, let's do another example. Let's arrange our oxygen flow meter to 1 liter per minute to 3 liters per minute. Always start with writing the formula. FiO2 equals liters per minute of oxygen divided by the liters per minute of oxygen plus the liters per minute of nitrous oxide. So now let's plug in our numbers. Well, we have 1 liter per minute of oxygen, and in the denominator we have 1 liter per minute of oxygen plus 3 liters per minute of nitrous. So notice that the total number of gases will always go into the denominator. Let's add this up. So 1 divided by 1 plus 3 equals 1/4. And when we convert that to a decimal, the FiO2 will be 0.25 or 25%. Okay, so let's do an example with an oxygen flow meter and an air flow meter because our formula is going to change a little bit. So we've done an example with oxygen at 2 liters and nitrous at 2 liters. So let's use the same 2 liters. Oxygen is 2 liters per minute and air is 2 liters per minute. So let's start by writing the formula. FiO2 equals liters per minute of oxygen. But now we actually have to account for the amount of oxygen that is also in the air. Because we know air is not all nitrogen, that the air contains 21% oxygen, we have to account for that in our calculation in the numerator. So essentially, the numerator should always address the total amount of oxygen divided by the total amount of gases. So the rest of our numerator will be 0.21 times the liters per minute of air. And this is a little bit different than if you're calculating the FiO2 strictly with oxygen or with oxygen and nitrous. Our denominator is the same. Liters per minute of oxygen plus liters per minute of air. So let's plug in our numbers. We have 2 liters per minute of oxygen plus 0.21 times 2 liters per minute of air, all divided by 2 plus 2. So let's add this together and we'll have 2 plus, and if we multiply 0.21 times 2, that will be 0.42, and then the denominator will be 4. So this will be 2.42 divided by 4. And if you have your calculator handy, 2.42 divided by 4 will give you 0.605 FiO2, or if you round up, 61%. Okay, so far we've been doing examples that only use 2 gases, but sometimes we're in a situation in anesthesia where we would like to use air, nitrous, and oxygen. So let's adjust our flow meters. We'll adjust oxygen to 1 liter per minute, our nitrous to 2 liters per minute, and our air to 2 liters per minute. So let's write our formula. FiO2 equals liters per minute of oxygen plus 0.21. Remember, we have to do this because we have to account for the 21% of oxygen that is contained in air times the liters per minute of air, all divided by the total number of gases. So the liters per minute of oxygen plus the liters per minute of nitrous plus the liters per minute of air. Okay, let's do the math. So 1 plus 0.21 times the 2 liters per minute of air, all divided by the sum. So 1 plus 2 plus 2. So this would be 0.21 times 2 is 0.42. So the numerator would be 1.42 divided by 5. And if you get your calculator, 1.42 divided by 5 is 0.28. So our FiO2 is 0.28 or 28%. Okay, let's do another example. Let's adjust our flow meter to read 1 liter per minute for each gas. So 1 liter per minute of oxygen, 1 liter per minute of nitrous, 1 liter per minute of air. Okay, let's write our formula. FiO2 equals liters per minute of oxygen plus 0.21 times liters per minute of air, all divided by the sum of liters per minute per gas. So liters per minute of oxygen plus liters per minute of nitrous plus liters per minute of air. Let's plug in our numbers. So there's 1 liter per minute of oxygen plus 0.21 times 1, all divided by 1 plus 1 plus 1. So let's add these things together. 1.21 divided by 3. And if you have your calculator handy, 1.21 divided by 3 is 0.403. So our FiO2 is equal to 0.403 or 40%. Okay, let's do one final example. So we have our oxygen flow meter set to 3 liters per minute, our nitrous set to 7 liters per minute, and our air set to 6 liters per minute. Let's write our formula. FiO2 equals liters per minute of oxygen plus 0.21 times the liters per minute of air, all divided by the sum of the gases in liters per minute. So liters per minute of oxygen plus liters per minute of nitrous plus liters per minute of air. So in the numerator, we have 3 plus 0.21 times 6, all divided by 3 plus 7 plus 6. Okay, so 0.21 times 6 will be 1.26. So our numerator will be 3 plus 1.26 divided by 3 plus 7 plus 6. That's 16. Let's add it all up. 4.26 divided by 16. And if you have a calculator handy, 4.26 divided by 16 is 0.266. The FiO2 is 0.266 or 27%. I hope you've enjoyed this lesson. Please stay tuned for additional videos on mathematical concepts.